Okay, this is about the initial theoretical part of what we needed. In pure rolling, once again, we'll summarize all the things. Pure rolling, what happens? There's a rigid body. This is directly what needed for the numericals. When we do numericals, no? Center of mass is moving with velocity vc. All points are rotating with angular velocity. Let r be the radius. This one. This is what p, that one. In pure rolling, what will happen? Velocity of point p will be 0. How you write velocity of point p? Vc minus r omega c. Due to Vc, what happen? It will have like this. R omega c will be like this here. I'm showing only the point of contact. What is the velocity of point P? Vc minus. Sir, why you are showing like this? Because if center of mass is having translative motion, all points should have translative motion due to center of mass. So Vc. Why R omega c? Due to rotating motion about center of mass. Agree this? So therefore, for pure rolling, what is the condition? Or should be like a pure rolling Vc equal to R. This is a condition they have defined it. So Vc minus Vc, this will be 0. So for pure rolling, what will be the velocity of point of contact? Will be 0. Will there be any friction will be acting? No, no friction will act here. Then what is the acceleration of point P? Acceleration of point P will be non-zero. Why non-zero? There will be an acceleration, no? Centripetal acceleration will be there. There will be some acceleration. Velocity of point P will be 0, but this one. So this I'll call now instantaneous center. Now, O is the instantaneous center now? Point P. What is the instantaneous axis of rotation? Axis passing through point P and perpendicular to plane. So all points now, if you are on the ground, what you say? Center of mass moving, all points are rotating. If you stand at point P, then what you should show? You are going to show the diagram like this. In which frame this is? The same discussion what happened? You can show like this here. Don't show omega c in the both the diagrams about P, about C. Here you have to show that one. Don't just leave it. That's all over this one. All points are rotating about incident with the same angular velocity. So now who has drawn this diagram? The person on the ground. Now who has drawn this diagram? The person at instantaneous center. And what he comment? All points are rotating about incident with angular velocity. Then how to calculate velocity of this point? What I should do? Just draw one diagram, no? How to calculate velocity of this point? Draw this and call this is R1, V1. Sir, I want velocity at this point. What you should do? I want velocity at this point. So from here, you just drop like this. This R2. And what is V1? R1 omega C. What is V2? R2 omega C. I think this will be much easier, no? We know omega C. R1 greater than R2. V1 greater than V2. I think it's very easy to compare now the velocity of these points, no? Now this is about pure rolling. So I'll bring the idea of forward slipping now. What do you mean by forward slipping? What do you mean by forward slipping? That angular velocity I'll show about center of mass, and let this be the radius r. This is a point P. Now the person on the ground is what is drawing this diagram. What do you mean by forward slipping? If Vc greater than r omega c, it's called as forward slipping. Let's see that what conditions will have. What is the velocity of point P? According to the translative motion, it should have velocity Vc. According to the rotating motion, it should have tangential velocity r omega c. Then what is the velocity of point P? How we define? Vp is equal to Vc minus r omega c. Vp, I think we are getting greater than 0. So net resultant velocity of point P in what direction will be like this. I'm showing 3 arrows is very important. What is that black color arrow? It's the resultant of VC and R omega C. Please do understand. It should be like this. Huh? VC minus R omega C. I'll draw a little bit bigger. I think you know vector idea. VC minus R omega C will get VP. So it is like this. Huh? This is VC. At least able to understand. I think uh, be more than this, no teacher can explain in the world. Then there's a problem with your brain. Take care of that one if you're unable to understand. And now, what is the velocity of point P? Towards right. And if this is rough, in what direction friction should act? Friction should always oppose relative motion. Tell me in what direction friction will act. The friction on the body will act towards left. I think I don't have. I'll show like this. So for forward slipping, resultant diagram, I'll just show only velocity and that particular thing. For forward slipping, look at now. So what is the velocity of point P? The resultant velocity of point P is like this. Then how the friction will act? The friction, because friction should oppose relative motion. So for forward slipping, Fs, I'll write it. So for when you introduce a rigid body with forward slipping, means how to check forward slipping? Vp greater than 0. Then now the friction at the lowest point will act towards left here. And then backward slipping. Now, so what is the next condition? We are defining backward slipping. In backward slipping, what conditions will arise? Vc less than R omega C. What is the velocity of point P? Will be like this. R omega C will be greater. Then the resultant velocity will be towards left. So then how you write it? It will be like this, no? Vp equal to Vc minus R omega C. R omega C is greater than Vc, then this will be negative. So less than 0 means negative here. Then what is the velocity of this point? The resultant velocity of point P will be towards left. And now your task question, sir, how it is possible? Then how the friction will act? The friction should act in this direction. This is called like a backward slipping. Where do we see this slipping? So suppose like you put when rain comes, and if the road is almost smooth, then if you put brakes, no, then what when the wheel will have more transitive motion than rotative motion. There's a forward slipping. Where do we see? Suppose if you take this particular vehicle, or if a bike or two-wheeler, four-wheeler, especially you can see the two-wheeler, no, if you are moving in some muddy roads, in village roads where mud will be there in rainy season, then what will happen? The wheel will rotate more than moving forward. There's a backward slipping. Sir, how to experience this? So you can do one thing, take cycle where rain comes and check there any ground is there. And if the ground is little bit slippery, then what when you can see that the wheel will rotate more than moving forward. What about forward slipping? The wheel will move more than rotating. So best thing when rain comes and if you're moving on a vehicle, like if you put brakes, then what the wheel will have rotating motion as well as translating motion. The wheel will have more translating motion than rotating motion. There's the forward slipping. Then the friction will act backward. When do we can see? When the mud roads are there, when you are moving this vehicle nearby sea beaches, river bank or seashore, or in muddy roads, that one where mud is there, there open if you are taking the vehicle, no, the vehicle will have more rotating motion than translating motion. Then now the friction will act forward. This was the practically what we can give examples here. So in pure rolling open, no friction will act, though surface rough, though it is rough. Why no friction? Anybody? Why no friction? Because what is velocity of point P? Zero, no? And according to the friction definition, what is that? The friction will always oppose relative motion between the surfaces. What is the velocity of the ground? Zero. What is the velocity of point of contact? Is zero. So no relative motion. But sir, body is moving. I think what is the definition of friction? Friction will always oppose relative motion between surfaces or between center of mass of the body and surface. No, between surfaces, no, we are not bothered velocity of center of mass. Then one more biggest problem for you, sir, like body moving towards right, friction acting backward. Okay, fine. So body moving forward, friction acting forward. How it is possible, sir? How it is possible? Body moving forward. So it's not about the velocity of center of mass will determine friction here. The point of contact here. The friction will always oppose relative motion. What is the velocity of point of contact? The relative motion between the lowest point of a rigid body and the ground. In what direction this lowest point is having velocity with respect to ground? Towards left. So therefore relative motion is there. Top of relative motion, friction will act here. So therefore, how to determine the friction acting on a rigid body? Will you take help of center of mass or will you take the point of contact? I will take help of point of contact. That's what here we are trying to conclude here. Getting the idea? Then if it's having a pure rolling, then how to find out velocity of any point or what is the path length, everything. No. In forward slipping, what will happen to this distance covered by the center of mass? This S will be greater than, SC will be greater than 2 pi r. Come back to this last data. In forward slipping, in pure rolling, SC will become equal to 2 pi r. SC will become equal to 2 pi r. Try to see this part. In pure rolling, this will become equal to 2 pi r. In forward slipping, what happens? This will become greater than 2 pi r. In backward slipping, this SC will become less than 2 pi r. So when do this discussion will come? In pure rolling only. In pure rolling only we are discussing this one. And what is the path of any point on a circumference will be cycloidal. So with every one time period of revolution, it come and strike the ground. And the center of mass will be moving straight. Points in rigid body, this is one point I'm just taking. You just imagine this point. Like the several points will have a very random path. No? It'll be very difficult to work out in the ground frame. You have to ask questions of why you are bringing instantaneous axis of rotation. Why we are bringing instantaneous center? Any reason for that? Because I can't work out from the ground, you see, in mathematics. This is for point P1 only. Like this for every point. Can you do mathematics of this kind? I think it's a stupidity, no? If you don't have any work, okay, go do that one. Something what happened, we want some immediately the answer, no? So therefore, studying the motion of rigid body from the ground frame will be very difficult to predict the velocity, to cover the distance, everything. So which is the best way of studying the motion of rigid body in pure rolling? It's about the instantaneous center. And all points and axis passing through instant center is called as instantaneous axis of rotation. Okay,